So shown on the screen are Poncelet triangles inscribed in an ellipse and circumscribing some generic caustic. I'm also showing over this family the elliptical locus of the orthocenter of these triangles, x4. And we have found experimentally that these are always inverse-homothetic to the outer ellipse, in the sense that they're homothetic to a 90-degree rotated copy of the outer ellipse. If I change the center of the caustic and I place it elsewhere, and I change a little bit its angle, you get this homotheity. Now, one of the things that you notice as well is that the center of the locus of x4 only depends on the center of the caustic. So if I, for example, gyrate the caustic, notice how the center of the orange locus does not change. Let's place the caustic elsewhere, for example, over here, like that. Yeah, let's go like that. And then I can gyrate by selecting a different desired angle for the caustic. But notice that as I gyrate the caustic about C, and behind the scenes here, there's a numeric computation to satisfy the closure condition. You can see that the center of the orange locus does not change, right? So it seems to only depend on the actual center of the locus and not its shape. Now, how many choices do I have here? If I specify the two coordinates of the center and the orientation of its major axis, which is what I'm doing in this video, I have a one-dimensional continuum of possible caustics that satisfy that. I have a randomization button and I can try different aspect ratio caustics here. And you can see here that as I flip through these, the center of my x4 locus does not change, giving us further evidence. Let me turn the caustic around a little bit like that. That center only depends on the actual center of the caustic and not on the shape of the caustic itself. Okay, so let's place the center over here and let's rotate it a little bit like so. Okay, and you can see that over the rotations of the caustic, the center of x4 does not move. Okay, and as I randomize the shape of x4 and I rotate it, that center is just dead stable. Okay, so that's what I have for this video.